Hi, this is Nancy Mansell coming to you from C&M Behind the Glass. Let's simplify some radicals. What we're trying to do here is we're trying to find factors of the number under the radical sign that are perfect squares or cubes or whatever your index is. So let's try this one, the square root of 24. 24 has lots of factors, 8 times 3, neither of those are perfect squares. How about 4 times 6? Oh yeah, 4 is a perfect square. So just like you can combine two of them under the same radical, you can split them out into two radicals. Why would I want to do this? Because the square root of 4 is 2, and that gives me 2 times the square root of 6. Now just between you and I think that that looks simpler than this, but this really is simpler. If you want to check it and make sure it's right, two things you have to check. You can plug both of these into your calculator and get a decimal equivalent. If the decimal equivalents are the same, then they are the same. The only other thing you have to check is that there is no perfect square factor of what's left under the radical sign. The only factors of 6 are 1 and 6, 2 and 3. None of them are perfect squares, well, except for the 1, but that doesn't count. All right, let's try another one. Square root of 108. Let's see, I think that's going to break down to the square root of 36 times the square root of 3. Okay. 36 is our perfect square. The square root of 36 is 6. So that gives us 6 times the square root of 3. Okay, what about this one, the square root of 10? Can I simplify that at all? The only factors of 10 are 1 and 10, 2 and 5. None of those are perfect squares, so that one doesn't simplify. You must be getting the hang of this because now we're moving to perfect cubes, and let's try this one. The cube root of 16. Well, 16 is not a perfect cube, but it has a perfect cube factor. That would be 8. So let's go cube root of 8 times cube root of 2. And why did we do that? Because the cube root of 8 is 2, and that gives us 2 times the cube root of 2. Good. How about this one? 16 m cubed. 16 m squared and m. Now, why did I do that? Why did I not break the 16 up, but I did break up the m's? Well, you're going to look at the numbers, and you're going to break them into perfect square parts and whatever's left over. And then you're going to do the same thing with the letters, the m's. Okay, so the square root of 16 is 4, and the square root of m squared is m. So that gives me 4m times the square root of m. What do you think? Ready to try a fourth? Here's a fourth for us. Negatives on the outside, good. It has to be because this is positive. Remember, it's not a real number if the negative was on the inside. So we're going to keep the negative. Let's see. I need a perfect fourth that is a factor of 162. That would be 81. So let's go 4th root of 81 times 4th root of 2. The 4th root of 81 is 3, so we have negative 3 times the 4th root of 2. And you can't see that, so let me rewrite it up here. Negative 3 times the 4th root of 2. Okay, one more. Okay, square root of 200k to the 7th, q to the 8th. We need to break this up into parts. So first we're going to look for perfect squares in the numbers. 25 is a perfect square, and it's a factor of 200. But something I failed to mention, you not only have to find perfect square factors, you have to find the largest perfect square factor. And the largest perfect square factor of 200 is 100. So what would I need to multiply to get back to my 200 here? A 2. Okay. Now, if this is even, it's a perfect square, but it's not even. It's a 7th. So we're going to take the next smallest even number, which will be 6, and what's left over? 1. And 8 is an even number, so that is a perfect square. Okay, now that we're done breaking everything up, let's go ahead and take the square roots of all the perfect squares. The square root of 100 is 10. The square root of k to the 6th is k to the 3rd. And the square root of q to the 8th is q to the 4th. So let's gather up all the stuff that came out of the radical signs. That's 10, k to the 3rd, q to the 4th. And whatever's left under the radical signs, we just put under the same radical. And that would be 2k. Good job. See you soon.